Hello everyone, I am Bhuneshwari, Assistant Professor, Department of Mathematics from St.Josephs College, Huzur. In this session, we'll discuss about the Laplace transform. First, we see the definition for Laplace transform. Here, you are taking the function f of t we have defined for all t greater than or equal to 0, then the improper integral. This is the improper integral because the one of the value is infinity. So this is called as the improper integral. This integral is defined as the Laplace transform of the function. If this integral value exists, we call this integral value as the Laplace transform of that function. So we are taking a function f of t here and we are finding the Laplace transform. That means integral 0 to infinity e power minus st into that function into dt. So after finding the value of this integral, we will get a function in s. That is, in terms of s, we will get the answer. That is f bar of s. So here we are transforming the function f of t to a function s. So we are taking the function in terms of t, will get the answer in s. So here we are transforming t to s. So L is called as the Laplace transform operator here. So here we will get the answer in s where I told you. So here s means it may be a real number or complex number. Here throughout this we assume that s is a positive real number here. First we will see that we are going to find the Laplace transform of 1. Some elementary functions. First, we are going to see the Laplace transform of 1. So we are already seen L of f of t is equal to integral 0 to infinity e power minus st into f of t dt. So we are going to find L of 1 means in the place of f of t, we are going to substitute here 1. So integral 0 to infinity e power minus st. In the place of f of t, we are having here 1. 1 into dt. It is equal to integral 0 to infinity e power minus st into 1 means e power minus st dt. So integration of e power minus st means e power phi t integration is e power phi t by t. So integration of e power minus st means e power minus st by minus s. So the limit is from 0 to, we are integrating it. After integrating, we are getting e power minus st by minus s. So the limit is from 0 to infinity. Here we are integrating with respect to t here. So s is constant. So I am taking it outside the bracket. Minus 1 by s is constant. So I am taking it outside. We are going to substitute the limits only for integration with respect to t. So we are going to substitute only for t here. Other s is constant. This term is not having t. So I'm not going to substitute here the limit. So I'm taking it. It is a constant. So I'm taking it outside the bracket here. So remaining, after taking minus 1 by s outside, we are having remaining the term we are having remaining is e power minus st. That is e power minus st. The limit is from 0 to infinity here. Minus 1 by s is constant. In the place of t, if we substitute upper limit minus lower limit. So in the place of t, if we substitute infinity, we will get e power minus infinity minus e power minus 0 we will get. So here minus 1 by s is constant. E power minus st means we know that e power minus infinity, e power minus 0. E power minus infinity, we can write it as 1 by e power infinity, and e power minus 0, we can write it as 1 by e power 0. So 1 e power infinity value is infinity. So 1 by infinity we will get here 1 by e power 0. Any number e power 0 value is 1. So 1 by 1. So 1 by infinity value is 0. And 1 by 1 is 1. We will get minus 1 by s into minus 1. 0 minus 1 is minus 1. So minus 1 by s into minus 1 is 1 by s. So we will get at last as L of 1. Laplace transform of 1 is 1 by s. S should be always positive here. S should be greater than 0. Next, we are going to find the Laplace transform of t here. We already know from the definition of Laplace transform, L of f of t is equal to integral 0 to infinity e power minus st into f of t dt. Here in the place of f of t, we are having here t. So integral 0 to infinity e power minus st into t dt. Here, two terms are here. So I'm going to integrate by integration by parts. So we have to choose one term as u and one term as dv here. So which when I differentiate, which term easily becomes 0, that term you should choose as u. Here, when I differentiate this e power minus st, you will get minus st. When I differentiate e power minus st into minus s, e power minus st into minus s, you will get repeatedly like that. But when I differentiate this t, where first time differentiation is 1, second time differentiation is 0. So I am having here, I am taking here t as u and e power minus st as dv here. So when from u we will get du as 1. From dv we will get v as minus e power st by from u. This is u. When we differentiate x with respect to x, we will get 1. Same way here also, when I differentiate t with respect to t, we will get du as 1. T I am taking as u. From that, du is 1. That is differentiation of t is 1. dv is e power minus st. From this, v is e power minus st by minus, as already I told you. E power 5t means integration is e power 5t by 5. Here, e power minus st by minus s. So we are going to substitute this in uv minus integral v du. U is t and v is what? E power minus st by minus s. Next, minus integral v is e power minus st by minus s. Du is 1 dt here. In this formula, we are substituting all these terms. U is t. Next, v is e power minus st by minus s, minus integral v is e power minus st by minus s. Du is 1 into dt. So when I put here e power minus infinity, wherever we are getting e power minus infinity, we should put 0. E power minus infinity, already we have seen that e power minus infinity means 1 by e power infinity. 1 by infinity, the value is 0. So the upper limit becomes 0. The same way, when we substitute 0 in the place of t, when we substitute 0, that also you will get 0. So upper limit also 0, lower limit also 0. So the whole term becomes 0 here. So I have to take only the second term. Second term is integration 0 to infinity e power minus st by minus s. Into 1 means the same term you will get into 1 dt. So here minus 1 by s is by minus s. I am taking this 1 minus 1 by s outside the integral. So I'll get minus of minus 1 by s here. So plus 1 by s. This is nothing but e power minus st into 1 dt means this is nothing but the previous Laplace transform. F of t e power minus st into 1 dt means from the previous Laplace transform of 1. Previous proof, we can say that L of 1 is equal to 1 by s. So 1 by s into 1 by s is 1 by s square. Similarly, we can prove that L of t square means we will get us 2 by s cube. L of t power n means we will get us n factorial by. That is, for t square, you will get 2 by s cube. For t cube, you will get 6. That is nothing but 2 into 3 like that you will get. So t power n means we can generally write it as n factorial by 3 into 2 like that you will get. So n factorial, n into n minus 1, up to 1 you will get. So n factorial by sn plus 1 you will get. So next is we are applying this in L of t cube means we will get as 3 factorial by s power 4. L of t power n means n factorial by s power n plus 1. So in the place of n, you are having here 3. So n means n factorial by s power this number plus 1. So L of t cube means 3 factorial by s power 3 plus 1, that is 4. Same way L of t power 4 means in the place of n you are having 4 factorial by s power 4 plus 1, 5. So we got us for L of t power 4 factorial by s power 5. So try this problem L of t power 5 minus 4t cube plus 3 and reply your comments. Thank you.